Hello, this is Mr. Stein, and in this video we are going to look at the properties of functions. We're going to look at the vocabulary and some basic operations. So by the time you're done this lesson, you should be able to define and give examples of functions. Identify functions in different representations. So if I give you an arrow diagram, you can tell if it's a function or not. If I give you a graph, you can tell if it's a function or not. Change a two-variable equation into a function and vice versa. Use function notation to determine the values of a function, and use set notation to list the domain and range of a function. All right, first off, we need to determine exactly what a function is. A function is a special type of relation. It either has to be a one-to-one relation or a many-to-one relation. It is a one-to-one relation or a many-to-one relation. It cannot be a one-to-many relation or a many-to-many relation. So if we were to just take a look at this and have a domain with item A, B, and C, and a range with 1, 2, and 3, if this one looks like this, this is a function. Every element of the domain goes to one thing in the range. Now in this relation, we actually would get rid of this 3 here, because nothing from the domain goes to that in the range, so it's not really a part of the range, is it? That is a function. If we look here, if A goes to 1, B also goes to 1, C goes to 3, and D goes to 2. This relation is a function because each item in the domain goes to only one item in the range. This is a many-to-one relation, but many-to-one relations are also functions. So what wouldn't be a function? Well, let's take a look at this. I'll do a table of values. Here's our domain, here's our range. A goes to 1, B goes to 2, B goes to 3. This one is not a function. The reason it's not a function is because this B value goes to two separate things. This is a one-to-many relation. The one element in the domain, B, goes to many elements in the range, 2 and 3. We often associate functions with mathematical equations. Function notation looks like this. Our function is named f. Our variable that it's on is x. So the function f on the variable x is equal to 2 times x. This is function notation. F is the name of the function. X is the domain variable. we should be able to convert from function notation to two-variable notation. Two-variable notation would look like this. Y equals 2x. The f of x part becomes a y. Okay, so here's another example of function notation. Our function g on the variable x is equal to cosine of x. So the function named is g, our domain variable is x, and this is the function here, cosine x. If I want to change this into two-variable notation, it becomes y equals cosine x. Anytime we have a general function name, f or g or h, with a small letter in front, we just change that into y. Let's compare it to this function right here. The cost for a certain number of people at a banquet is equal to $250 up front plus $12 per person. This is function. This is in function notation. Our function's name is c, cost. This is the cost function. N is our domain variable. It's the number of people. So, how do we change this one into two-variable notation? In this one, we keep the c as our range variable. C is equal to 250 plus 12n. We just drop that brackets around the n. Drop that whole part out. So as you can see, if it's a general function, so g of x or f of x or h of x, we change the g of x or f of x or h of x into just y. If it's a specific function, we take our domain variable out and we just replace it with a single variable that is the name of the function. All right, my iPad is messing up a little bit, so I will reset this again before we move on to the basics. All right. Here's our function. If our f of x, our function on x, is equal to 2x plus 3, then find the function evaluated at 2 and the function evaluated at negative 2. In the brackets is our x values. So that is what we're going to substitute in for x to solve this. Now, just quickly, I'm going to turn this into two-variable notation. F of x equals 2x plus 3, and two-variable notation be y equals 2x plus 3. You don't need to write that down right now, but I'm just showing you how to change it from function notation to two-variable notation. Now, let's solve the first one here. Our function evaluated at 2. Our function evaluated at 2 will be equal to 2 times 2 plus 3. We take this value right here and we substitute it in for x. And now we solve it. 2 times 2 is 4, plus 3 is equal to 7. So our function evaluated at 2 is equal to 7. This would give us the point on a graph of 2, 7. All right, let's look at the second one. The function evaluated at negative 2 would be equal to 2 times negative 2 plus 3. Right? Negative 2 gets substituted in for x. And then we're going to get negative 4 plus 3, which will give us negative 1. And then this will give us a point on the graph when x is minus 2, y is minus 1, or our function is minus 1. So you should be able to take a function and evaluate it at certain values. Now I could put this all together into a small table of values that looks like this. X and our function, evaluated x. When x is -2, our function evaluates to -1. When x is +2, our function evaluates to +7. All right, let's do the same thing with number 2. If our function g of x equals x squared plus 4, then find the function g evaluated at 5 and the function g evaluated at -10. Now just quickly, I want you to write this in two-variable notation. It would look like this. Y equals x squared plus 4. That's two-variable notation. You need to be able to convert from function notation to two-variable notation. Now let's evaluate this function at x equals 5. So our function g evaluated at 5 is equal to, not x, we replace the x with a 5. 5 squared plus 4. Our function evaluated at 5 is going to be 25 plus 4 is equal to 29. This is going to give us a point on a graph at 5 for x, 29 for y. Let's look at our second one, our function evaluated at -10. Our function evaluated at -10 is equal to -10 squared plus 4. Now, -10 squared is equal to 100. This is where the parentheses are very important, right? In my original function, that the entirety of x is squared. So in this case, x is -10. So -10, the whole thing is squared. So I put parentheses around it to make sure I highlight that. It's 100 plus 4 is equal to 104. So we have another point on our graph at x is -10, y is 104. Now likewise, I could build a table of values for this. X and my function g of x. When x is -10, g of x is 104. When x is 5, g of x is 29. If I wanted to draw a good graph of it, then I would need to do more points to figure out what this graph is doing. Number 3, if h of x is equal to 2x plus 1, for what value of x will our function h of x equal 9? Now this one's working backwards. Up here, question number 2, we were given an x value, and we figured out the function. In this one, we're given the function value, and we're asked to figure out the x. Okay, now, it's important that you notice here, h of x equals 9. Right here is my h of x. Now, I know that h of x is equal to 9, so I can replace this h of x with 9 because they're equal. So this h of x gets replaced with 9 is equal to 2x plus 1. Everybody see that? Because the h of x is equal to 9, I can replace this h of x with 9, and then now I can figure out my x value that would give us that. So I'm going to subtract 1 from both sides to get 8 is equal to 2x. Divide both sides by 2 to get x is equal to 4. Now this would give me this point on the graph. X would be 4, and my function is 9. So this way, this type of question is backwards from the previous questions. It's important in math that once you can do a question one way, so up in number 2, we were given the x, and we were asked to find the function. In this question, we were given the value of the function, and we were asked to find x. So, anytime you get an operation in math that you are going to learn how to do, you have to learn how to do it forwards and backwards. Okay, so by now you should know what a function is. You should be able to know what a function is and give some examples of functions. You should have an idea about identifying functions in different representations. You should be able to change two variable equations into a function. You should use a function notation to determine values of a function. And we will look at this last one in the next video when we go through the example problems. All right, if you have any questions, put them in the comments below or contact me directly. And thank you for watching.